So welcome to, thanks. Welcome to our environmental systems seminar, and thanks for navigating to a different time. Hope everyone's doing well today. It's our pleasure to welcome Dr. Aditi Mukherji. Apologies for the pronunciation. She's director of the CGIAR Climate Impact Platform. And prior to that, she was a principal researcher at the International Water Management Institute based in India. And she has also done some work leading the water and air theme at the International Center for Integrated Mountain Development in Nepal. Aditi was the coordinating lead author of the water chapter in the Working Group 2 of the International Panel on Climate Change, IPCC, published in 2022, and is a member of the core writing team of the IPCC's AR6 synthesis report, which was just recently published. So she has a broad area of expertise and specializations in groundwater governance, energy, irrigation, nexus, climate change, adaptation, and community management of water resources. So we're very happy to have her here and excited to hear about some of her work on those IPCC efforts. So we'll turn it over to you, Aditi, and thank you for joining us.
Thank you, Sam, and thank you everyone for this opportunity. Thank you, Shafiq, for making the connection. Today, I'm going to talk about the recently released IPCC synthesis report, which was the culmination of 6 reports that were published in this assessment cycle. So there were 3 special reports, and then there were 3 working group reports. I am assuming that there is a general understanding about the IPCC process, but feel free at any point to just stop me and ask clarification questions. So the synthesis report itself is a relatively short document, which was quite a feat given that we were tasked with the task of literally summarizing 8,000 pages worth of literature, worth of documents. These 6 reports I'm mentioning were around 8,000 pages into 30 pages. I think we kind of did 30 pages then, because this happens through the summary for policymakers happens through a process where it goes by line approval. The final content increased a little bit because the governments wanted to include certain things that were there in the underlying report. I can't remember exactly where we ended, but it's still a report that's less than 50 pages for sure. So it's a relatively short, targeted document that is saying where we are in terms of climate change, what are the impacts, but most importantly, what can we do about it? So that's in brief what my presentation is going to be, and I am going to use the figures in this report, both the longer report. So there are 2 parts of the synthesis report. One is the summary for the policymaker, which gets approved line by line, sentence by sentence by 193 governments who are a part of the UNF of the IPCC. And then there is a longer report which gets adopted page by page. So some of the figures come from the longer report and some of the figures come from the summary for policymakers. And many of us are using these figures because we believe that the figures are able to say the story in a more engaging way. But please feel free to read the actual report, and I'm happy to answer questions to the best of my capacity. And yeah, it's okay to stop and ask questions in the meanwhile, if that's the way you usually do. So the first big finding is about human activities are responsible for global warming, but not all have contributed equally to emissions that have caused warming. So here we have a sentence which is like one of the headline statement that says human activities, principally through emissions of greenhouse gases, have unequivocally caused global warming, with global surface temperature reaching 1.1 degree above 1850 to 1900 in 2011-2020. Basically, it means that we are now 1.1 degree above the pre-industrial temperatures, which was between 1850 to 1900. Global greenhouse gas gas emissions have continued to increase with unequal historical and ongoing contributions arising from unsustainable energy use, land use change, lifestyles and patterns of consumption and production across regions and between and within countries and among individuals. So I feel that while we all know that it's really fossil fuel and the emission of greenhouse gases from other sources which have landed us up where we are in a world that's 1.1 degree warmer, this report is quite unique in that it also actually points out to some of the underlying reasons, and one of that happens to be lifestyles and patterns of consumption and production. So there is a lot of inequity involved there, and the report is quite candid about trying to find out the underlying root causes of climate change. I don't know if it may be worthwhile to say that the synthesis report has three main sections. The section where I was mostly involved is around what has happened in the past and in current situation, both in terms of emissions, but also adaptation and mitigation action. Then we had the second section, which was SPM2. So this current and present and past was SPM1. SPM2 was around our long-term actions, what happens in the long term, and long term is like 2050, 2040 onwards. And our section SPMC was around what happens now, that is the near term from now till 2040. So that was the timeline along which the report was constructed. And there is this longer report, underlying longer report, which corresponds to section 2 was around current and past. Section 3 was around long-term future, and section 2 was around near-term. Section 3 was around near-term action. In case you're planning to read it, this time division helps in doing that easier. So the first one, these are some of the figures from the longer report from one of the sections that I was facilitating. Here we are saying that human activities are responsible for global warming. I think another thing that might help here in comprehension is that this is the synthesis report does not bring in new science to the fore. The synthesis report's job is to synthesize what has been already published in the 6 underlying reports. So we are summarizing the main findings from the entire cycle, while the individual underlying report's job is again not to do new science per se, but to assess the existing peer-reviewed published material. So in some ways, the synthesis report is a synthesis of those peer-reviewed literature. So that's kind of where the synthesis report sits in the overall scheme of things. So our first one was around human activities are responsible for global warming. This is greenhouse gas emissions from different sectors, fossil fuel and industry, land use and land cover change, and non-CO2 emissions, including methane, nitrous oxides, and others. This is how it has gone up over since 1850. Now, if we zoom into another figure that shows what has exactly happened to the concentrations, we now have more concentrations of parts 410 ppm of CO2 and 1866 parts per billion of methane, etc. These are some of the highest concentration known in anything between several thousand years to several millions of years. So which has resulted, these emissions and concentrations of greenhouse gases have resulted in global temperature rise. We are now at 1.1 degree above the pre-industrial level, and this has been the observed warming, of which this much is the attributable one, and various gases, well-mixed GHG, have contributed to it, and some like aerosol, including short-lived climate pollutants, have caused some cooling effect. But these are all drawn from the working group 1 of the assessment cycle, which was originally published in 2021. Then we also find that Working Group 1 mostly worked on concentrations of greenhouse gases, while Working Group 3 worked on emissions, and they also looked at where the emissions actually come from. because in terms of physics, it doesn't matter where the emissions comes from, but for policies, it matters a lot. And working group 3, that is around mitigation, looks largely at mitigation policies. So while working group 1 is in some ways agnostic about where those emissions came from, for working group 3, this is of core importance to locate these emissions. So what we find is that historical cumulative net anthropogenic CO2 emissions per region from 1850 to 2019, and these are the numbers for each of the continents, with North America being the highest contributor to historical cumulative net anthropogenic CO2 emissions. And then if we look at a particular year, 2019, that was the latest available at the time of writing this working group 3 report, we find again per capita emissions are highest again in the developed world. So if historical ones are highest in North America, followed by Europe and Eastern Asia, when it comes to per capita emissions, that's North America, followed by Australia, Japan. And some of the lower per capita emissions are seen in Africa as well as Southern Asia. I think most of you are aware of these differences and why they matter. So this brings us to our second important one, where we are saying that climate change is affecting everyone. So, I mean, at this day, it's unlikely that we have almost everybody has experienced climate change in one way or the other, or knows somebody who has experienced climate change firsthand, be it in these catastrophic events or extreme weather events that causes wildfire in California, or floods in Pakistan, or these very intense tropical cyclones anywhere on Earth. So almost everybody has experienced climate change. But those who are least responsible for climate change, that is the ones who have emitted the least, are being most disproportionately affected. So accordingly, we have a headline statement, which is also quite bold, where we are saying vulnerable communities who have historically contributed the least to current climate change are disproportionately affected. And all of this is publicly available, so please make sure that you download and read. Each of these sentences are constructed with a lot of care, and as I said, each sentence is approved line by line by the government, which means that the synthesis report is a document that has been co-produced by hundreds of scientists, but also 195 nations of this world. So this is a fantastic example of science policy interface, where an important document like this is co-produced, which means every country in the world literally agrees with these findings because they have actually approved it with us scientists who were involved. So coming to another figure where we are saying climate change has impacted human and natural systems. These are some of the fantastic figures from Working Group 1, where they have prepared a stylized map of the world to show what kind of impacts have happened. And these are examples of hot extremes, and you can see almost every region on Earth has experienced hot extremes that is statistically very, very significant. Not only are they significant, but they are also high confidence that it is human emissions that has caused this change. So there has been a great improvement in attribution in this cycle. So you can see pretty much in all the regions, we can see that hot extremes have increased, including heat waves. And this is actually observed from 1950s till current. So this is not something projected. This has already happened. And what we find is there are places with low data availability where we do not know, where we don't know, but chances are the same thing has happened in those places as well. Then when it comes to heavy precipitation, again, we have examples. This is like increase in heavy precipitation we are seeing in a lot of places. Here the confidence is somewhat low than heat because of, I think most of you are aware how precipitation has many other drivers. So there's always more tricky than just temperature. But even having said that, and there's also the issue of data networks, etc., but we still see that majority of the areas have experienced increase in heavy precipitation since the 1950s. When it comes to agricultural and ecological drought, the same thing, a large number of regions have seen an increase in agricultural and ecological drought, and there are actually a lot of regions where the low agreement in the type of change. It is possible that this low agreement is due to data issues, and the hope is that often when IPCC assesses something as not having enough evidence or low agreement, that kind of becomes a reason for more research. So we can hope that during the next cycle, many of these regions where we are seeing low agreement in type of change would have more definitive results. That certainly happened between AR5 to AR6. In AR5, the previous cycle, for example, if you go through it, you will see that there was much more examples around, much more content around future projected impacts and much less on current documented impacts, because those impacts, those studies were missing. But then over the last 6-7 years, there have a lot more studies have come in with the current documented impact. So that's something I think these knowledge gaps would be hopefully filled by the next cycle. What's important is that here we have mapped, this comes from Working Group 2, where we have mapped the vulnerability of population through a composite index which measures risk with emissions per capita. And not surprisingly, the most vulnerable countries generally have lower emissions per capita. These are the countries where their vulnerability is very high. And you can see that their emissions per capita is very low. Emissions per capita are high on this side. So emissions are on this side and vulnerability index is on this side. And this kind of drives home the point that those who have emitted the least also happen to be the most vulnerable. Then we have looked at, this also comes from Working Group 2 report, where we have looked at the impact. So when it comes to various of these impacts, water availability, food production, health and well-being, cities and infrastructure, and within that individual components, we are seeing mostly adverse impacts, and with some cases, we are seeing adverse and some associated positive impacts. Physical water availability being one of those where there are some positive impacts, but overall adverse impacts outweigh positive impacts everywhere. Now, when it comes to the similar is the story for ecosystems, which includes changes in ecosystem structure, species, and changes in seasonal timing. So that gives us one set of story. Then to continue, and these are some of the figures from the summary for policymakers, which says the figure SPM1, which I have seen very popular on Twitter, for example, where we are seeing that adverse impacts from human-caused climate change will continue to intensify. I'm not showing you the first two blocks because you already saw another version of it a while ago. But this is a figure which I think says this very clearly. These are the warming stripes that have been very popular in the popular media, and the IPCC has adopted it for the very first time, where it shows depending on where you are born. So any child born in 2020 would be 70 years old in 2090, and that child would have experienced a way more warmer world than their grandparents born, I don't know, in 1960s or something. So, and people born in 1940 would have seen, so basically life experience, depending on when you are born, and those children born today would experience a much warmer world, and how warm that world would be would really depend on our action. It is possible to limit that warm world to a very low to a low warmer world if we take action today. If we don't take action today, then that world becomes high to very high. But also what's not quite there in this figure, but it's there all throughout the report, is that not only when you are born, but where you are born also matters. If you're born in a country that's highly vulnerable, then there's very little chance of doing well in this very high level of warming vis-a-vis countries which are less vulnerable. But overall, what remains true is that for us, the best bet remains remaining within these low to very low levels of warming. Now, going back to the long-term future or near future, we are saying that with every increment of global warming, regional changes in mean climate and extreme becomes more widespread and pronounced. So for example, what happens at different levels of global warming, 1.5, 2, 3, and 4 degree. Currently, we are at 1.1 degree. We are here. This is what we are at present. But if it's like 2 degree, then annual hottest day temperature change becomes hotter and hotter. So annual hottest day temperature is projected to increase most 1.5 to 2 times the global warming level in some mid-latitude and semi-arid regions and in South American monsoon regions. So not only would overall globally temperatures increase, but some regions get more impacted than others. Similarly, the similar thing happens with annual mean total column soil moisture change. These changes mostly follow projections in annual mean temperature, but also show some differences due to influence of evapotranspiration. These are some of the information coming from both Working Group 1 and Working Group 2. Similarly, we are seeing annual wettest day precipitation change across different temperature levels. At the same time, we are seeing similar changes when it comes to risk, projected changes to risk to species loss at 1.5, and the species loss becomes much more intensive at a 4 degree, 3 degree world. Heat, humidity, and risk to human health, it's a similar story. I mean, basically, figure after figure, it's a very similar story. We have then 2 examples from agriculture and food production, what happens to maize yield at different temperature levels and what happens to fisheries yield at different temperature levels is again the same story. Every increment of warming matters for these impacts. This brings us to the SPM figure 4, where we are seeing that risks are increasing with every increment of warming, something that we already saw in the previous figure. Here, IPCC uses something called these burning embers, which is one way of showing the different risks. And what it shows is that compared to AR5, due to better modeling and better data and better computing facilities, and we are able to actually say that many of those risks that we had identified in AR5 are actually projected to happen much sooner. So things like unique and threatened ecosystems. So earlier, if high risk were somewhere there, now we are expecting the similar amount of risk at a lower temperature. It's not as if the physical basis has changed. It's just that my understanding is that I'm not an expert in this particular ember diagram, but my understanding from conversation with other fellow scientists has been that much of it is related to our better science and computing facilities. So to be more concrete, what's happening is that things like we are seeing a lot more risk also differ by system. For example, when it comes to wildfire damage, as soon as 1.1 degree, currently we are seeing increase in length of fire season. And by a higher temperature, we would see over 100 million additional people exposed to something like wildfire damage. So a similar story overall around permafrost degradation, biodiversity loss, etc., etc. So we have done this for land-based system, ocean and coastal ecosystems, etc. That brings me to the SPM figure 5, which is then saying, so now so far we have seen that emissions, human emissions are causing impacts. Impacts are pretty bad at 1.1, but they are projected to become worse with every increment of warming. So now what can we do about it? So what's important is limiting warming to 1.5 and 2 degree involves rapid, deep, and in most cases, immediate greenhouse gas emissions reduction. So this is kind of absolutely the core action. And we find that our implemented policies are resulting in a projected emissions that lead to a warming of 3.2 degree. Well, remember that I saw some lot of discussions going on around this. So it's not as if IPCC is saying it's worse than what we knew, 3.2 degree, while after some of the submissions of NDCs by the governments in the last COP, other scientists have projected this to be around 2.7 degrees. The thing is that IPCC's cutoff dates were before the submission for COP27. So some of the most recent government actions or government intentions, rather, like we don't know the implementation part, at least the intentions have not been captured. But having said that, it's still pretty grim. If it's not 3.2, it's certainly 2.7. And we have already seen from the previous figures that 2.7 is also pretty grim. So what we need to do is that our current implemented policies takes us by the end of the century to a pathway that leads us to 2.7 to 3 degrees, which is just way too warm. But if you want to limit warming to 2 degrees, and if you want to limit warming to 1.5 degrees, then those emission cuts needs to start right away. I mean, by 2025, we should have already reversed, we should have reached peak emissions. Instead of that, if anything, emissions have been going up. So this is, I think, pretty grim. Similarly, net global CO2 emissions, these are the different pathways by which emissions need to start going down. And if this graphs actually started earlier, then you would have seen that the need for the emissions to go down would have been much less drastic. Because we have not taken action for decades and decades and decades, now we have to reduce emissions drastically, which could have been avoided if actions were taken way back from 1990s, when we knew that climate change was real and happening. So this brings us to this, what I call an inspirational figure that has more around a schematic that is showing how action needs to be taken. This is not so much as a data figure, but as a way in a schematic diagram showing the policymakers that there is a rapidly narrowing window of opportunity to enable climate resilient development, which this figure basically shows that the actions we take now, whether we want to if we don't take action, then what we are getting into a world which has high emissions, entrance systems, reaches adaptation limits, there's maladaptation, versus we have, a system where there is low emissions. So it all depends on the actions we take. And then there are conditions that enable those actions, finance being one of them, but also inclusive governance, diverse knowledge and values, all kinds of things, and conditions that constrain those actions. So I think that's the kind of what this figure tries to show, that our future depends on the action that are taken today, and that actually determines our course for the next several thousands of years. For some systems like glaciers and others, which takes millennia to come back once they have melted. Then the final figure, and I will stop here and will be happy to take questions and talk a bit more about adaptation. Unfortunately, we did not have any compelling figure on adaptation except this one, but the report has a lot around adaptation, has a lot around loss and damage. So our final figure says that there are multiple opportunities for scaling up climate action. Those are both in the sphere of adaptation, and then we have divided those actions by different sectors. Those include settlements and infrastructure, health, society, livelihood, and economy, like various kinds of adaptation actions, various kinds of mitigation actions, and what is the potential of those actions in reducing climate-related risk. So there's a whole lot of actions in energy supply, land, water, and food. Some of the work that I personally do are around water use efficiency. I know many of you, Shafiq works on water as well. A lot of the work in food sector. So all of them have very high potential in reducing, in preparing for better impacts. What's also new in this report is that there is a lot of focus also on demand side management, which literally means changes in lifestyles, changes in energy efficiency. So a lot of benefits can be done simply by reducing losses in food loss, like waste of food. Similarly, demand management can work wonders for anything like electricity, electrification. So demand side mitigation literally means that we have to reduce the demand, but we can still do it without affecting quality of life to a large extent. So a lot of it is talking about unsustainable use of resources and using more resources that affects equity overall. So with that, I would like to stop. This is something, one of my favorite quotes. This is how the Working Group 2 report ends. The scientific evidence is unequivocal. Climate change is a threat to human well-being and health of the planet. Any further delay in concerted global action will miss the brief, rapidly closing window to secure a livable future. Thank you, and happy to take questions. I hope I have not exceeded my time limit. Thank you.
Great. Thank you so much, Aditi. That was a wonderful presentation. So yeah, we're open for questions now. So feel free to either drop your questions in the chat, or you can raise your hand in Zoom and I will call on you, or even feel free to just unmute yourself and start asking your questions. So we'll turn it over to the audience and see what questions you have.
Yeah, maybe I can start. So Aditi, this is a fascinating talk, and I was really intrigued by your comment where you said that the report only captures the promises made by the countries, not their implementation, right? And I'm just curious if there are any effort either through this, IPCC or some other, means tracking whether the governments are actually following their commitment and whether those commitments are actually making any dent to the emission or not.
Right. I think there is. So in the section on mitigation, we are talking of three kinds of gaps. Basically, sorry, two kinds of gaps. One is the ambition gap. We are saying that the government actions are not ambitious enough. So basically, the actions that the governments are putting in are taking us to a 2.7 to 3.2 degree pathway. But at the same time, we have also identified what we are calling as the implementation gap. Not only are the ambition, that is the government pledges, not ambitious enough, but there is also a gap in implementation. So there is a bit of detail in that in the longer report section 2, and as well as in parts of SPM A4, where you might want to look at further detail. And I think Working Group 3 mitigation does quite a bit of work on tracking both ambition gap as well as implementation gap, to the best of my understanding. Yeah.
Thanks.
I have kind of I guess a process question. So I feel like IPCC regularly produces some of the best like science communication and data visualization products out there. And so I'm just curious if you could kind of talk a little bit more about your experiences and kind of working on or contributing to the development of those visuals, like the ones you shared here, or other ones that show up in the report. Like, how do you kind of go from, okay, we have this kind of synthesized results or synthesized data, how do we and then take that to kind of these compelling and very informative visuals? And like, are there approaches or techniques that you think could maybe transfer to other activities or other researchers? Okay.
Yeah, no, that's a fascinating question. And it's the process I saw was for one, multiple people contribute to these figures, and they're coming from different perspectives. So some of these figures are truly integrated. One of the figures that I showed you around the impacts were coming from more of the physical impacts coming from Working Group 1. So then some of the impacts are natural and human systems coming from Working Group 2. So every figure then had representatives from the different working groups and scientists. Some of them were natural scientists, some of them were social scientists. And usually it starts by drawing something much rough on as simple as a whiteboard. And then there is also a graphics person who worked with us very closely, Arlene. She's mentioned in as a graphics designer, and basically that she helps develop these figures. In the underlying report, also we get similar help from the working group technical support units, but the original figures, the idea has to come from the authors based on the work that they have done and the synthesis they have done. And then with the help of these technical support units, I think these come in, but it goes through a lot of iteration till the very last minute. And in the instance of the synthesis report, of course, we also had this limitation that we couldn't do new things, in the sense that it had to be already there in the underlying report. So working within that limitation, there was also from each of the working group, there was this co-chairs were involved in something called like a more of a figures group. So every figure was being presented to them, and they were providing feedback. So no, a lot of work goes into these figures, for sure. I hope that answers your question, Sam. Yeah, okay.
There's a question in the chat, and I can read that to you, Aditi. As an Indian ambassador to the Intergovernmental Panel on Climate Change, how do you give feedback to your own country according to AR6 information that you are relevant or you presented? Yeah.
Right. Even though we may be nominated by our countries, I personally wasn't. I was nominated by one of the observers. I was nominated by ICIMOD, but irrespective of who nominates you, when we are at the IPCC, we are working as scientists. So we try not to wear our country hat during the negotiation process. So irrespective of what your country might ask you to do, as writers, we hold the pen. So for us, it's important that the scientific integrity is maintained. And once the document is approved, is as much as a document of Government of India as it is a document of us who wrote it, as much as it is a document belonging to all of you who are listening to this. So once the document is approved and published, all of us can use it absolutely the same way for disseminating the information that's in there. So if that answers your question, so yeah, we are not supposed to be wearing our country hats during the negotiation process at all. But if that was not your question, I'll be happy to hear what you meant.
Thanks. Anyone else?
Yes, I have a question. Thank you, Aditi, for the presentation. And I think you mentioned something about being nominated by your country. And I just wanted to know a little bit more, how is the process to end up being part of the writing team, and how has been your experience in that process?
Right. So the process is that usually the IPCC Secretariat reaches out to the country focal points. Every country has a focal point or a focal ministry who are supposed to nominate scientists for the IPCC's different reports. And you should be able to find much of that information on IPCC's website. And if you're interested in, and every country does it a bit differently. I mean, in India, for instance, again, my nomination, I used to work with this intergovernmental organization called ICIMOD, and many intergovernmental organizations have observer status and have the ability to nominate. So I got nominated through that, but different countries have different methods of nomination. I heard one country mention that they even advertised in newspaper asking for scientists to volunteer. In some countries, scientists can simply go and get in touch with their country focal point and volunteer. And I believe it's also possible to self-nominate through IPCC website. I haven't checked that myself, but I've heard it that it's possible. So I'll be happy to put you in touch with somebody else from the IPCC who might have more information about the nomination process than I have. I just got nominated and selected, so I may not know everything that goes behind it. But I'll be happy to, if you write me an email, I'll be happy to put you in touch with relevant people.
Thank you.
Anyone else? Well, meanwhile, I have another question for you, Aditi. On the climate impact side, it's pretty obvious that people who are contributing the least are getting hit the hardest, right? But also on the adaptation side, I feel like that, there is a environmental justice and inequity issue, because a lot of the people who cannot afford the solutions that are being presented end up bearing the cost of everything, right? So just to give you an example,
Yes.
when it comes to implementing solar power, right, in urban areas, it's basically poor, and people who cannot afford, putting a solar on their homes will end up paying for the grid. The same happens to the roads, right? So things like that. And I'm just curious what your thoughts are on this side of the equity and environmental justice issue.
Yeah, no, that's a very important point, and I think it is quite clear in one section, that's A3, that talks about adaptation. B4 again talks about adaptation, and C3 talks about adaptation in the report. And this kind of comes out very clearly that the adaptation gaps are highest among the low income groups in vulnerable countries. It just so happens that in hindsight, I feel that we didn't really have that figures, like graphical figures for adaptation to showcase. So when I use this figure slide deck for telling the story, somehow the adaptation story wasn't as well said as it could have been. But in written text, there's a lot around adaptation that actually captures the unequal contribution and the unequal impacts and what it means for adaptation. We also talk about losses and damages and how those losses and damages are also unequally felt. And so there's actually a lot of content around that as well in the report. Not shown visually, graphically, unfortunately.
Yeah, thanks. Because I think in the context of here in California in particular, I think there was, I think the solar was promoted heavily, but then the question came back, who's going to pay for the grid? And now there is a levy that, that the utilities are trying to put in. So if you try to bring solar now, I think the incentive is not, that high. So I think there's like multiple moving pieces that, kind of act as a barrier and also, the equity issue. Yeah.
Absolutely. Yeah. We are seeing many places having these perverse incentives that actually favors fossil fuels. So subsidies for fossil fuels are still higher than investments in renewable energy. And that's shocking standing in 2023 when we know that we have such a narrowing opportunity for limiting to 1.5, and it seems pretty inevitable that we would cross 1.5 by the middle of the next decade. And even then, I mean, the state I come from, India, I was recently shocked at in West Bengal. Some states are doing very well with rooftop solar. In my state, I was trying to do this rooftop solar, and I was told that the government doesn't allow net metering. So I would have to I could do a rooftop solar, but I have to install an equipment that prevents the electricity I generate from feeding into the grid. And that makes no sense, which means then I have to then invest in a battery for nighttime use, while grid connected solar would have been so simple. And so many states in India are using grid connected solar. So we do have those kind of huge policy incoherence that makes absolutely no sense.
Yeah, indeed. Yeah. Yeah, there's another question in the chat, I believe. Says the latest report has mentioned social impacts more explicitly. How are technical and social scientists working together, communicating and coming up with mitigation solution or mitigative solutions rather?
Yeah, that's an amazing and an interesting question. I think what happened, I can give you a specific example also from my working group too. I was the coordinating lead author of the water chapter in the working group that looks at adaptation, vulnerability, and impacts. And my own chapter, I was one of the coordinating lead authors, and we had 12 lead authors, of which 50% were physical/natural scientists and 50% were social scientists. Half of us were from developing country, half of us were from global north and global south. Half of us were women, half of us were men. So it was a truly diverse group of scientists. And I think it was just completely inspirational how well we worked together, given this common goal of producing a report. I can't tell you exactly how it happened. It's just simply happened that all of us could align our goals. I mean, and I cannot say that it happens in every instance or every chapter had this success story, but overall, what IPCC has done very successfully in AR6 compared to AR5, and I hope they continue on this path, is they have been very particular about diversity and inclusion, given the criticism that they had got earlier that it was very global north, male dominated, scientific based. So they were missing out on a lot of other perspectives. So I think they took care of that. And that had its own challenges. But at the end, I mean, the synthesis report, we were a core group of 30 authors, everybody with very different backgrounds and very different lived history, lived experiences. But we ended up working very well because we had a like a clear set of instructions. This is a 30-page report you have to produce based on 8,000 pages of, 8,000 pages of published reports. So I thought that was that kind of pretty daunting task just puts us all together to come to and deliver what we have been selected to deliver. So it just worked. I don't have a magic formula that I can tell you, but it's just like fantastic group of scientists and human beings who just come together and say that it's just extremely important that we do this well and we put aside our whatever individual differences we might have. Yeah. Thank you.
Yeah, Wendy, go ahead.
Hi, just to kind of follow up on that, I wonder if there might be some sort of simple principles that might come out of this for people who are making decisions on a more granular level, like local governments who may not fully understand the science so well, but if they had some very simple guidelines to go by, they could sort of judge how their policies impact climate change and mitigation, like something like focus on fossil fuel use reduction, like really simple parameters by which they could measure or evaluate the policies that they're considering and how they might impact climate change mitigation.
Yeah, no, that's fantastic. Yes, I think that's completely doable. Again, as I said, this report is in the public domain, and I know for sure that a lot of civil society is using it to craft these kind of simple messages for their constituencies. So I think similar ones can be done for local governments. Totally, the report can form the backdrop, but these, and I have always felt, and today in an earlier discussion, I was just saying that I have worked in Bhutan, and in that country, what happens is it's a small country, a beautiful country, but importantly, any policy that they have, it goes through a nodal ministry called Ministry of Gross National Happiness, because Bhutan's objective is to maximize their gross national happiness as opposed to gross, national income. But every policy goes to their Ministry of Gross National Happiness, and they scan those policies to see if it kind of in tandem with their overall objectives. So similarly, I think that this is high time that we do that with all policies in our countries. We scan those policies to see if those policies promote climate mitigation and climate resilience, and then that's how we judge policies. Unfortunately, we don't do that, or we are not doing that fast enough at the pace that's needed. But I think local governments are one of the best places to start influencing. Yeah. Thanks.
Nina?
Yes, that was really where I was going with this, was with my question was that one of the things that I see is that where we have local governments across the country who are really looking at the impact of oceans rising, or the impacts to fisheries, or the jellyfish off the coast, or all these things that are indicators of potentially indicators or genuinely indicators of climate change, we see people really pulling together to make changes. And while California is supposed to be so fantastic at really addressing climate change, and they have a climate change strategy, I see San Diego has a climate change strategy. it's not enough. It really, if we can't address what's really contributing to greenhouse gas emissions, it's not enough if we're not really trying to get public transportation in, for example, so that we can move people long distances without a car. But we don't have adequate public transportation. And so, you know, I was on a call that had a woman from Germany, and she says, we are putting trains back in where trains used to be. We used to have trains all over the place. That was how people were moved. 100 years ago, people were moved by trains. But I see no movement back to providing those sorts of transportation to reduce the dependence on the automobile here in California, because this is a place that kicked out all the public transportation to make way for automobiles. So in some ways, we're drastically responsible for greenhouse gas emissions rising, and yet we hold it in our hands to change that. And I don't know if you really have thought about that kind of those kinds of actions, and how maybe in the future you're going to come up with a system for scoring people on how successful they are or unsuccessful they are. Because I think that people need to understand when they're successful and when they're not successful, because governments are kind of blind to many things.
Right. No, you raised very interesting point, Nina. We do have a transport sector decarbonization features prominently in the report and also in the Working Group 3 report, and public transport like fossil free, and trains are one of those great examples of, you know, especially if we have a clean grid and these trains are running on electricity, then clean public transport comes as one of the top list of effective climate actions that you can take. That along with transport within cities, so that a lot of around the cities being mobility friendly. I happen to know that a lot of US cities aren't that friendly for walking or the way the cities are designed, but there is a lot of evidence around the benefits of a city where you can walk easily or you can take public transport around. Then there are also added benefits if the cities have lots of trees, and evidence around how trees keep those neighborhoods, hot neighborhoods, cooler, and all of that. So no, it's very much a part of it, and it's at the end of it, it's not really rocket science. I think all of us understand that at the end of the day, it's the decisions and the consumption choices we make. Sometimes we make because we don't have options, like for example, taking a car out for the lack of public transport, and sometimes we make those options in spite of having options, like the decision to still take a car out even if we have public transport. So I think that understanding is there, that it's our actions that are resulting in these kind of, and I feel that of course as IPCC we our mandate is not to be policy prescriptive, so we cannot say country A or B to do this or that. Our job is to provide evidence, scientific evidence and assessment, which we do. Now it really depends on the governments, but more importantly on the citizens to advocate for those changes. Yeah, over.
Okay, so I think we have one last question in the chat, and I know it's getting late back in India, so we'll try to end with that. The question is, India seems to be increasing the use of coal to support its efforts to reduce energy poverty. How do you view this policy?
Obviously not a policy in the right direction, but even more interestingly, what's happening is you would not have thought, but I believe UK opened a coal mine recently that it had closed. So I think Ukraine war has doing weird things to even countries where you wouldn't think that coal was coming back. India, for instance, this is India's position, official position is around that we have only caused 4% of the global emissions. Our per capita emissions are very, very low. So therefore, and that the carbon budget, the remaining carbon budget, so we have very little carbon budget remaining. The reason being that the rest of the carbon budget has been used by the developed world to develop themselves and their citizens and to create wealth, which is literally leading them to be less vulnerable, while countries like India still haven't. I don't really subscribe to that view. I think that it is possible to develop without polluting, but for that, what you need crucially is climate finance. And climate finance, if there's something quite remarkable about it, is its absence. So the report also, again, I think the figures do not quite do justice to the fact that one of the main highlights of our report has been the total lack of climate finance and how less of this goes actually to those communities and countries in need. So yes, overall, not a great idea by anybody to increase coal. But then climate action also has this equity and historical responsibility perspective. So, and countries have their own, political economy to grapple with. Over.
All right, with that, join me in thanking Dr. Aditi Mukherji for taking the time and sharing her insight with us.
Yeah, thank you so much. Yeah, thank you.
Thank you. Thank you for staying up late.
Yes. Thanks.
Thank you.
Bye.
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 Bye.